Assalamu alaikum. Today we will be reviewing some selected questions from October 2024 Unit 1. So now let's move on to question number 4. Question number 4, it says you have two flasks. One flask contains 4.0 into 10 to the power minus 3 moles of methane. The other flask contains 160 milligrams of a different gas. Now you are to find the identity of the gas in flask B. Now these are two identical flasks, right? And they contain different gases. Each flask contains one gas with the gases at the same temperature and pressure. If the gases are at the same temperature and pressure, and if these are two identical sealed flasks, then these two gases must have the same number of moles. Okay. Since they are at the same temperature and the same pressure and the same volume, so they must also have the same number of moles as well, because the temperature and pressure is the same and the volume is also the same. So the number of moles of gas must also be the same. So in flask B, you already know the number of moles, because since you know the number of moles of methane, the number of moles of gas B, so the moles of gas B will be equals to 4.0 into 10 to the power minus 3. And you already know the mass of the gas B, which is 160 milligrams. You convert this into grams, this will become 0.16 gram. Now if you calculate the molar mass of gas B, this would be 0.16, which is mass, divided by the number of moles. So if you divide this, the answer comes out to be 40 grams per mole. Now this 40 grams per mole, this molar mass corresponds to argon. So the answer to question number 4 is argon, is A. Okay. Then we move on to the next question. The next question is question number 6. Question number 6, it says 10 grams of copper metal was added to excess silver nitrate solution. The silver metal was collected, washed and deionized as water and left to dry. What is the mass of silver metal collected, assuming a 100% yield? You can easily calculate this. You have 10 grams of copper, you have excess silver nitrate. 10 grams of copper. What you can do is you can find the moles of copper, which is 10 divided by 63.5. 63.5 is the relative atomic mass of copper. So if you divide it by 63.5, you get the moles of copper, and the moles of copper equals the moles, it doesn't equal the moles of silver. So the moles of silver will be 2 multiplied by the moles of copper, because the mole ratio of copper and silver is 1:2, so you have to multiply by 2. Then you find the mass of silver, which is 2 multiplied by 10 divided by 63.5 multiplied by the relative atomic mass of silver. Let me find the silver atomic mass. Silver relative atomic mass is 107.9. So if you multiply, so this comes out to be 10 divided by 63.5 multiplied by 2 multiplied by 107.9. So the answer comes out to be 34 grams. So your answer will be between 20 grams and 40 grams. Alright? This will be the answer. You could also estimate instead of calculating, since I have calculated here. This could also have been estimated. This answer could have been found even without a calculation. See, the mole ratio of copper is to silver is 1:2, right? So the moles of silver will be doubled, and the relative atomic mass of silver is much higher. So definitely, the mass of copper, the mass of silver formed will be more than twice of the mass of copper, because you have to double the number of moles here, and you have to multiply by a relative atomic mass which is much larger than the relative atomic mass of copper. All right. Okay. Now we move on to question number 10. Question number 10, it says, which statement is not correct for these period 3 elements? B is incorrect, because the chloride ion and the sulfide ion, they have different ionic radius. These two ions are isoelectronic, and the sulfide ion is larger than the chloride ion. This is definitely larger than the chloride ion, because it has a greater negative charge. There is greater repulsion in sulfide ion compared to the chloride ion, and that is why, and that is why the sulfide ion has a much larger radius than the chloride ion. So the answer to question number A must be B. So this is an incorrect statement. Atoms of chlorine have the highest first ionization energy. That is a true statement, because when you move along the period, there is an increase in ionization energy. The ionization energy would increase, right? Atoms of sodium have the larger atomic radius. Yeah, sodium has the larger atomic radius, because when we move along the period, the atomic radius decreases. Atoms of phosphorus has the most unpaired electrons. True, phosphorus is the most. It has 3 unpaired electrons. If you write its electronic configuration using the box notation, you will see phosphorus has the greatest number of unpaired electrons among these elements. Now we move on to question number B. Which of the elements has the strongest intermolecular forces? Strongest intermolecular, they are talking about intermolecular forces. Intermolecular forces are present only in these elements, phosphorus, sulfur and chlorine. Because these are metals, they don't have intermolecular forces. Silicon is a giant covalent molecule. Silicon contains only covalent bonds and not intermolecular forces. So if you compare these three, see, sulfur has the greatest melting temperature, or the highest melting temperature, which indicates sulfur has the strongest intermolecular force. So the answer to this question will be B. All right. Now we move on to the next question. It says, which of them reacts with chlorine to produce 4 different monochlorinated products? Monochlorinated means when it reacts with chlorine, it forms a compound with only one chlorine. Monochlorinated means when it reacts with chlorine, it forms a compound with one chlorine. It's asked which one of them will react with chlorine and form 4 different monochlorinated products. That it would form 4 compounds. It will form 4 different compounds. Now, if you look here, if we compare isomer X, when we compare isomer X, so if you react with chlorine, so one chlorine can be substituted here, another chlorine can be substituted here, one chlorine can be substituted here, and another chlorine can be substituted here as well. So this compound can form isomer X. So isomer X can form four different monochlorinated products. So let me draw this for you. The isomer X. Let me draw all the 4 compounds. So one chlorine can get substituted here. So one chlorine can get substituted here. One chlorine can get substituted here. One chlorine can get substituted here. So isomer X will form 1, 2, 3, 4 compounds. Okay. Let us talk about isomer Y. Isomer Y these are isomer Y. Let's check how many isomers can it have with monochlorinated products. One chlorine can substitute here. One chlorine can get substituted here. That's it. Y will only produce 2 monochlorinated products, not more than 2. So Y will produce 2 products, right? This is isomer X, that's isomer Y. Now look at isomer Z. Isomer Z is this compound. Let us check. So one chlorine can get substituted here. I think I made a mistake here. It would look like this. Yeah. Sorry. Okay. So one chlorine can get substituted here. One chlorine can get substituted here. Move from this. Looks too busy. Another chlorine can get substituted here. And another chlorine can get substituted here. So you get 4 different products from Z as well. So you get 4 products from X, 2 products from Y, and 4 products from Z. So your answer to question number C, will be B. Question number 13, my bad. So the answer to question number 13 will be B. B is the answer, isomer X and Z only. I move on to the next question. Question number 14, it says which step in the mechanism is an initiation step? Now see, it's very, very easy to answer this question because it says which reaction is an initiation step. Now in the initiation step, a stable molecule will break down to form free radicals. You have a stable molecule which will break down and will form free radicals, mainly 2 free radicals, right? So there is only one equation that indicates that a stable molecule is breaking down into free radicals, which is option A, because all the other options don't have a stable molecule forming 2 free radicals, right? So this is similar to the homolytic fission of the chlorine molecule when the ultraviolet radiation is shown onto chlorine when reacting with alkanes. See what happens, a chlorine molecule breaks down into 2 chlorine free radicals, right? So you compare this initiation step with all the 4 equations. So this matches only the equation in option A. So your answer would be A. It was a quite straightforward question. Question number 15b. It says cyclohexene can form addition polymers. Yeah. Which diagram shows 2 repeat units of this addition polymer? So you have to form the addition polymer from cyclohexene, right? You have to show 2 repeat units when 2 cyclohexene molecules join. So let me show you. So you have, let me draw here, you have 1 cyclohexene molecule here. You have 1 cyclohexene molecule here. It has a double bond here, right? And if you take another cyclohexene molecule, and if I place the double bond here, now if you react them, since it would undergo addition polymerization, these molecules would join at the carbon atoms where they had double bonds. Now this compound has a double bond here, and this compound has a double bond here. So when they form addition polymers, these double bonds won't be there, and they would form, it will form a bond between them, because the double bonds are here, right? The double bonds are here, and that is why they would form a covalent bond here, and the double bonds would disappear, and they would form one bond here and one bond here. This bond would bind to another monomer, this bond will bind to another monomer, right? So this answer matches with it matches with option D only. So D is your answer. It matches with option D only. Let me show you how. Let me give the number of carbon atoms. It would make it easier for you. For example, if this is carbon number 1, 2, 3, 4, 5, 6, right? So that's carbon number 1, 2, 3, 4, 5, 6, right? See, this joining is on carbon number 2, so this joining is also on carbon number 2. This continuation bond is on carbon number 1, right? So I hope you got the answer. Number C. What mass of cyclohexanol is needed to make 7.2 grams of cyclohexene if the yield of this reaction is 72%? Oh, the yield is 72%. You need to find the mass of cyclohexanol. Whenever you are asked to find the mass of the reactant, you need to find the theoretical yield. You need to find the theoretical yield of the product first. So initially what we do is we find the theoretical yield of cyclohexene. Theoretical yield of cyclohexene will be 7.2 divided by 72%. So 7.2 divided by 72% would be 10 grams. So this is the theoretical yield of cyclohexene. Whenever you are asked to find the mass of the reactant, you must always find the theoretical yield first. So theoretical yield will be mass divided by the percentage yield, the actual yield divided by the percentage yield. 7.2 is the actual yield, divided by the percentage yield will give you the theoretical yield of cyclohexene. Then what you do is you find the moles of cyclohexene. Moles of cyclohexene will be mass divided by the molar mass. Molar mass is 82 of cyclohexene, right? So moles of cyclohexene will be equals to the moles of cyclohexanol, because the mole ratio of cyclohexane and cyclohexanol is 1:1. Then you find Therefore, you find the mass of cyclohexene required. Cyclohexanol required will be equals to 10 divided by 82, which is the number of moles, multiplied by 100, which is the molar mass of cyclohexanol, and your answer comes out to be 12.2. 12.2 is the answer. So therefore, answer to question number C is D. Okay, now we move to question number 16. Question number 16 is says which is the correct identification for each double bond. For this particular double bond, for the double bond number 1, this is clearly an E isomer, because for double bond number 1, this is the high priority group, because on this double bonded carbon you have a CH3 group and a hydrogen. Definitely the carbon here is greater priority. And if you look at this double bonded carbon atom here, this double bonded carbon, it has two groups, one is CH3 and one this big group. So this whole big group is the higher priority group. Now when the higher priority groups are on the opposite side, then it's an E isomer. So double bond 1 is an E isomer. Alright? Okay. Then if you look at double bond number 2, so if you look at double bond number 2, on this particular carbon, this double bonded carbon has two groups. One is a CH3 group and another is a big group. So the big group is the high priority, is the higher priority one. And on this double bonded carbon, you have a hydrogen and you have a C2H5 group. Definitely the C2H5 group has higher priority. Again, here around double bond number 2, there are two different groups on the opposite sides of the double bond, right? Since these are on the opposite sides of the double bond, it's also an E isomer. So your answer would be, definitely the answer would be A. Answer to this question is A. A is the answer. Okay. Now we move on to section B. Section B, question number 17. You asked to explain question number 17, A3. A3, okay. You have to calculate the value of X in sodium hydroxide dot XH2 using your answer to A2 and the equation for the reaction. What was the answer in A2? The answer in A2 has to be found from the graph, and from the graph, let me check from the graph if you find the mass of NaOH dot XH2O. I think it was found out to be 5.8, I think it was 5.8 grams. If you plot a graph and you figure out the answer, it would be around 5.7 to 5.9. Let us take 5.8 grams, yeah. And using this mass, you have to find the moles of X, right? So what we know here is the mass of sodium hydroxide dot XH2O. Sodium hydroxide dot XH2O is 5.8 grams. Now the mass of sodium hydroxide is 4 grams. So that's 4 grams, 4.0 grams. So from this, what we can do is we can find the mass of water. You can calculate the mass of water. Now if you subtract the mass of the hydrated sodium hydroxide from, if you subtract the mass of the anhydrous sodium hydroxide from the hydrated sodium hydroxide, you get the mass of water. So the mass of water will be equals to 5.8 minus 4.0. So this equals 1.8 grams. So 1.8 grams is the mass of water formed, right? Okay. Then what we do is we find the moles of sodium hydroxide. Moles of sodium hydroxide would be mass divided by the molar mass. Molar mass of sodium hydroxide is 40. If you find the molar mass of sodium hydroxide, sodium is 23, oxygen is 16, hydrogen is 1. So the total comes out to be 40. So 4 divided by 40 will be equal to 0.1 mole, right? So then you find the moles of water. Moles of water is 1.8 divided by the molar mass of water, which is 18. So it is found to be 0, it's 1.8, yeah, 1.8 divided by 18 is also 0.1. So therefore, the moles of sodium hydroxide is to moles of water equals 0.1 is to 0.1. It is 1 is to x equals to 1 is to 1, right? Because the moles of water according to the equation was x. So therefore, x must be equal to 1. This should be our answer. So it was a pretty easy question. All right. Okay. Now we move on to the next question. The next question you asked me to solve was question number 20C1. It says complete the diagram by putting crosses to show the approximate melting temperatures of boron and nitrogen. We have to put crosses. To show the approximate melting temperatures of both boron and nitrogen, right? Now, if you look at boron, boron must have a melting temperature between beryllium and carbon, because in this period number 2, we studied in the class already, this period number 2, the highest melting temperature is actually of carbon. Carbon is the highest melting temperature. As we move along the period till carbon, the melting temperature increases. The melting temperature increases till carbon, right? So the melting temperature of boron will be somewhere between beryllium and carbon. Boron will have a higher melting temperature than beryllium, because boron is also giant covalent, right? So in case of boron, the melting temperature will be somewhere around here, maybe. It has to be greater than beryllium and less than carbon. You should ensure that. So it can be so this melting temperature can be anywhere here, anywhere. You can put it anywhere here. It doesn't matter. It doesn't really matter. All right. But it shouldn't go very close to the carbon, right? It should be less than carbon. Then we have nitrogen. Nitrogen is a simple molecule, and nitrogen, since it's a simple molecule, it is a gas, it should have the lowest melting temperature out of all these elements. So it should have a melting temperature lower than lithium. It should be much lower than lithium, much lower, right? So what you do is you draw the cross here. You draw the cross here. Much lower than the melting temperature of lithium. Then we move on to the next question. It says thallium also forms ions containing chlorine. For example, the TiCl4 3 minus ion. In this ion, thallium has 10 electrons in its outermost shell. So they have already told you that thallium has 10 electrons in the outermost shell. Now phosphorus in phosphorus 5 chloride also has 10 electrons in its outermost shell. Okay. Draw the shape of the TiCl4 ion and predict the bond angle. Now, in order to predict the bond angle and in order to draw the shape, you need to know the dot and cross diagram of TiCl4 3 minus, right? Now, if you want to draw the shape of the TiCl4 3 minus ion, now it says thallium has 10 electrons in its outermost shell. They have already told you that it has 10 electrons in the outermost shell, right? Now, if you draw the dot and cross diagram of this TlCl4, let me show you. This is Tl, and you draw a dot and cross diagram. It says it has 10 electrons in the outermost shell. Okay, it has 10 electrons. Okay, and it's TiCl4 3 minus. Okay. we can give 4 chlorine atoms up to here. And what we have here, we must give a lone pair here. Now, how do we know that there is a lone pair here? Because the question said this thallium has 10 electrons in its outermost shell, just like phosphorus. It has 10 electrons in its outermost shell, right? In this particular ion, the thallium atom or the thallium ion will be surrounded by 10 electrons. Okay, if it is surrounded by 10 electrons here, then so there is 1 pair, 2 pair, 3 pair, 4 pair. So now there is 8 electrons. So in order to have 10 electrons, there must be a lone pair, right? So this dot and cross diagram is a 5 electron pair system. 1, 2, 3, 4, 5. If you have 5 electron pairs, then the shape should be trigonal bipyramidal. This is how the shape looks like. If you remember, we studied in the class already. This is the trigonal. This is the trigonal bipyramidal shape, right? Now, see, it also said that PCl5 has also 10 electrons in the outer shell. So basically, they ask you to derive the shape of this molecule from the shape of PCl5. Now, since PCl5 has 10 electrons, PCl5 has the shape of what? PCl5 has the shape of trigonal bipyramidal. This is the trigonal bipyramidal shape, right? But they didn't ask for the shape of PCl5. From the shape of PCl5, you can easily derive the shape of TlCl4 3 minus, right? So what you do here, you replace the phosphorus by Tl, and since there are 4 chlorine atoms, you replace this bond with the lone pair, right? So this would be the shape of this ion, TlCl4 3 minus. And they asked you to show the bond angle. There are 2 different bond angles here. One bond angle will be around 120 degrees. Another bond angle will be 90 degrees, right? You can also decrease the bond angle by 2.5 degrees. For example, you can decrease the bond angle by 2.5 degrees, this bond angle 120. Because if there is one lone pair, it decreases the bond angle by approximately 2.5 degrees. But in the marking scheme, they have said if you give 120, that's correct. If you give a bit less than 120, that is also correct. For example, if you give 90, they have given correct. Even if you give a bit less than 90 degrees, because there is a lone pair, and lone pair will decrease the bond angle by approximately 2.5 degrees. You can also give this angle as 90 degrees minus 2.5 degrees, right, which is 87.5 degrees. That is also fine. You can give this as 87.5 degrees, that is fine, and you can give this as 117.5 degrees, that is also fine. That's also all right. Both will be correct. So this would be your answer. And it's the end of this paper. Thank you. Assalamu alaikum.